Thank you to AnyDesk for supporting PBS. The sunset on Mars is not like the sunset on Earth. These are color images of Martian sunsets and sunrises captured by Martian rovers and landers. They show us something unexpected. The colors of the Martian sky are the opposite of Earth, red in the day and blue near sunset. But what's even weirder is that billions of years ago, the daytime sky on Mars was much more like our own. In this video, we're gonna find out why the Martian sky used to look more like ours, why its sunsets look so strange today, and what that has to do with whether Mars may have long ago had life of its own. Hey smart people, Joe here. Today, Mars is a dusty planet wrapped up in a thin atmosphere that's 95% carbon dioxide. But Mars and Earth once had a lot more in common. We've collected a ton of evidence from orbiters, and satellites, and rovers that's helped us piece together a picture of a planet that billions of years ago was warmer, wetter, and bluer than that dusty red planet we see today. Sound familiar? To understand why, we have to go back to the beginning. Like Earth, Mars formed around 4.6 billion years ago. As clouds of cosmic dust were fused together by gravity, heavier metals sank toward the core. The combination of kinetic energy and heat from decaying radioactive elements heated the core of the growing planet into molten iron. The movement of molten metal in and around the core generated electric currents. And similar to current moving through a wire, all that moving electric charge gave Mars its second similarity to Earth, a magnetic field. We know that Mars had a magnetosphere because we found magnetic rocks on Mars' surface. You see, these can only be formed if a magnetic field was present as they heated and cooled. Those would make the coolest fridge magnets in the solar system. The magnetosphere also gave Mars some extra protection from the dangers of space. It could deflect streams of particles emitted from the sun, the solar wind. The magnetosphere worked like a bubble-wrapped force field to protect Mars' atmosphere and the gases in it from being ripped away by that wind. But what kinds of gases were in the ancient Martian atmosphere? Well, luckily, rocks on the surface of Mars and Martian meteorites found on Earth preserve fingerprints of the ancient Martian atmosphere, like little chemical time capsules. By analyzing certain minerals and tiny bubbles of gas, we've learned that Mars used to be surrounded by many of the gases we have in Earth's atmosphere, like nitrogen, molecular hydrogen, carbon dioxide, and water vapor. These gases would have created a greenhouse effect, absorbing and trapping heat from the surface of Mars and creating conditions that would have allowed liquid water to form. In other words, ancient Mars was quite a bit different from the big red ball of dust and ice we see today. When we look closely at the surface of the red planet, we can see evidence of branching river channels, dry lake beds, and other formations that look a lot like aquatic systems on Earth. Plus, it's still got ice today, which is made of water. That didn't just show up by magic. And Martian geology gives us clues too. A rare form of quartz, which only forms during highly explosive volcanic eruptions, similar to the one at Mount St. Helens, was picked up by the Curiosity rover here in the Gale crater. And another mineral, which only forms on Earth in hot underwater events, was found by the Opportunity rover here. These tell us that Mars had an extensive system of massive volcanoes, which pumped out even more of those critical greenhouse gases into the Martian atmosphere. So when we follow all those rocky breadcrumbs, they paint a clear picture of a warmer, wetter planet that was pretty similar to Earth. And that ancient planet would have shared Earth's famous blue skies and red sunsets, thanks to a phenomenon called Rayleigh scattering. Now, when light leaves the sun, it contains all the colors of the rainbow. But as those light waves enter the atmosphere, they cause gas molecules in the atmosphere to electromagnetically wiggle. And that wiggling scatters the light in different directions. But gases in the atmosphere don't scatter all light wavelengths the same. The specific gases in the atmosphere of Earth or ancient Mars scatter blue light more than the other colors. So when light enters the atmosphere like this, blue light from all over here is getting bounced around. So that if you were standing down here, the sky above you looks bright blue. And since we're subtracting out blue from that white sunlight, that ancient Martian sun would probably even look yellow, just like it does in our own sky. But when the sun is near the horizon at sunset, something different happens. Sunlight has to travel through a much thicker chunk of atmosphere. more of the blues and even some of the greens are scattered out, leaving just the longer wavelength reds and oranges around where the sun appears. And that's why sunsets change the sky from blue to red. So for a long while there, Mars was all blue skies and I don't know, maybe even rainbows. But Mars' blue skies wouldn't last. See, sometime after 3.7 billion years ago, Mars' electromagnetic field switched off. We don't find any more magnetic rocks formed on Mars after this time, which equals no more magnetosphere. It turns out that if a planet wants to keep its magnetosphere, size matters. And unfortunately, Mars is afflicted with little brother energy. It's only half the diameter of Earth and only 11% of Earth's mass. Much like how a small cup of coffee loses its heat a lot faster than a big one, Mars' smaller size made it cool off faster than Earth. Its molten core solidified, erasing its electromagnetic force field. Now, exposed to the solar wind, Mars' atmosphere was ripped away. And without that protective atmosphere, the Martian climate became drier and colder, with only patches of frozen water ice remaining today. And Mars went from Earth's brother from another planetary mother to this. And today, the Martian atmosphere is much thinner than ours. For every 100 molecules of gas that Earth has, Mars has 1. And instead of those ancient gases, it's full of floating dust particles, rich in iron oxides, basically floating powdered rust. It's actually all that iron oxide that gives Mars its nickname, the Red Planet. But that dust is also the reason the colors of the Martian sky are the opposite of ours today. Now, in Rayleigh scattering, the particles doing the scattering have to be way, way smaller than the wavelength of light, things like gas molecules. But the dust particles that fill the sky on Mars are about the same size as the wavelengths of light, so something else happens. It's a process known as Mee scattering. Now here, when light waves collide with larger particles, the waves bend around them and scattering mostly in the forward direction. Just like how light is scattered around headlights in the fog. This kind of scattering doesn't care as much about the color of light, so all colors will get scattered. On Earth, it's the reason clouds are white and why dusty days look hazy around the sun. Those larger particles of water and dust are scattering light toward our eyes. Now here on Earth, our dust and water vapor come in all different sizes. But when an atmosphere is filled instead with dust particles of a very specific size range, something strange can happen. Near sunset on Mars, why do we see this halo of blue light around the sun? Recall that Martian dust particles are around the size of visible light wavelengths. But those dust particles are a very narrow range of sizes that just so happen to have a very tiny preference for ever so slightly scattering blue light forward. So near sunset on Mars, as the light travels through a long path of suspended dust, that tiny bit of blue scattering leaves a halo filled with more blue light near the sun. And that's why a Martian sunset looks like this. This has even happened on Earth after volcanic eruptions, when our own air was full of clouds of fine dust of just that right size, leaving silvery blue halos around the sun and even the moon. Thanks to decades of exploration of our planetary neighbor, we know that 4 billion years ago, Mars had blue daytime skies made by ancient geologic processes belching gases into the young planet's atmosphere. And this leads us to the biggest question of all. Does that mean ancient Mars could have had biological life? Now, just like the fossil record on Earth has helped us understand our own planet's journey from molten rock to pale blue dot, studying the Martian landscape is giving us an even better look into the long history of the now red planet. For example, Viking landers did experiments where Martian soil burped out gases when it was fed nutrients. That's a process that can be triggered by biological activity. And we found a meteorite containing what looks like mineral grains that bacteria create here on Earth. But the biggest clue was uncovered in 2025, when the Perseverance rover collected a rock sample from an ancient riverbed. The rock core contains minerals and chemical compounds such as mudstone, organic carbon, sulfur, phosphorus, and oxidized iron. When we find those things on Earth, they're linked to biological activity. The rover also documented these colorful leopard spots, which are made of minerals that can be produced by microbes. Now, if scientists can prove that those minerals can only be formed by living things, that would be a huge hint that Mars once had life. Right now, Sapphire Canyon's the strongest evidence we've got that Mars may have had ancient life. But like every other clue that we've found on the red planet, there's a catch. Now on Earth, the artifacts that tell the history of life as we know it, they can't be produced by anything other than life itself. On Mars, we still can't be so sure. Soil can produce gas, minerals can form in meteorites, and leopard spots can show up in rocks because of life doing its thing, but all of these things can also be caused by chemical reactions and geological processes that have nothing to do with life. So we still have a lot of ground to cover, literally, if we want to figure out if Mars was once Earth's living, breathing cousin. The good news is we haven't even explored most of Mars. While orbiters have mapped almost all the surface, 99% of it remains unexplored on the ground. From rocks to riverbeds to sunsets, we've been slowly piecing together a picture of what Mars was like a long time ago. And as technology improves, maybe we'll find evidence of life on the red planet, or maybe we won't. But it'll be worth the search. Stay curious. And thank you to AnyDesk for supporting PBS. AnyDesk was created because whether you're in a remote location or just working from home, the need for reliable, secure communication and data transfer remains important. With AnyDesk, secure direct file transfer bypasses the cloud entirely, allowing you to move large media files, benchmarks, logs, or firmware updates between systems. And if you need to run complex systems, AnyDesk offers remote server monitoring and CMS access that allows you to control dashboards and monitor web servers directly from your phone or tablet. Or if you need to set up remote 3D printing access, you can combine AnyDesk with computer modules to run, monitor, and print from just about anywhere in the world. AnyDesk is available for personal use, but if your research requires a lot of global coordination, AnyDesk offers custom-tailored business plans. To learn more about AnyDesk, go to anydesk.com/besmart or check out the link in the description. Thanks for watching this video, and speaking of things that give us life, thank you to everyone who supports the show on Patreon, like these fine folks at our top tier. Head over to the link down in the description so you can support videos just like this one, find about new videos before anybody else, and, feel good about yourself for what you're doing about the world. Thanks. Sky.
All right, rolling.
I love how they fall apart at the end. I made that last line up. How about that? Nailed it.